Hello everyone, hope you guys are doing well. In today's video, we are going to be covering a very important topic of AdMaths, and this is a topic that you guys have requested quite a few times. And the topic here is polynomials. So what I've done here is I have basically written down all the key concepts that we have in this topic, okay, and I'm going to read them out to you one by one. And there are some topics that have been recently added as I've written over here. Okay, so the first concept is remainder and factor theorem, okay, very simple. Then you have solving or factorizing a cubic equation. So this is something that's difficult. And if you're wondering why have I put these colors next to it, that's because I will with this document. By the way, I'll share these notes with you guys. I'll leave a link to it in the description. You can download them, print them, share it with your friends, classmates, whoever you think can possibly benefit from it. Okay. And whoops, sorry about that. Okay. So, and then there's cubic curve sketching along with cubic inequalities, which as I've written over here is something that has been recently added. Okay. And then there are other key concepts which include long division and identities. And along with that, in this document, I'll attach some past paper questions. Okay. And which we're going to solve, by the way, in this video. And we're going to solve 2020 and 2021, both the sessions, October, November, and May, June, and both the variants. Okay. And the reason why I've chosen these two is because in 2020, these two concepts were added in the past paper. Okay, now let's get straight to it. So the first concept that we have is called remainder and factor theorem. Okay, now what this means is if the question is asking you, so first we're going to look at it generally and then we're going to do some example questions to understand it better. So what this means is if the question is asking you to find the remainder when a certain polynomial p of x is divided by x minus a. So there are just two steps to it. All you got to do is in the first step, just whatever the divisor is, which in this case is x minus a, set it equal to 0 so that you know what value of x to plug in. Okay, and that brings me to the next step. And the next step is that you're going to plug in that value of x in the polynomial, and whatever you get is your remainder. Okay, now that's remainder theorem. What exactly is factor theorem? Well, in factor theorem, if whatever you're plugging in happens to be a factor of that polynomial. So let's say if you divide 9 by 5, okay, so 5 ones are 5 and the 4 is the remainder. But if you divide 9 by 3, so since 3 is a factor of 9, that means in that case the remainder is going to be 0. Okay, so let's make a note here. That note, if x minus a is a factor of p of x, so in that case the remainder will be equal to 0. Remainder will be 0. Okay, so it's just something you need to remember. And of course, we're going to do some example questions right here so that you understand exactly what I mean. Okay, so let's do the first example, part A. In part A, you have x cubed plus 2x squared minus x plus 3, which is basically divided by x minus 1. So what's the first step? The first step is that I'm going to set x minus 1 equals to 0. So I know what value of x to plug in. And the value of x that we need to plug in is 1. So that means 1 cubed plus 2 times 1 squared minus 1 plus 3. So 1 cubed is 1 plus 2 minus 1 plus 3. Okay, so what do we have? We have 1 plus 2 is 3, 3 plus 3 is 6, 6 minus 1 is 5. So that means the remainder when this polynomial right here is divided by x minus 1 is 5. Okay, now we're going to do part D. In part D, what you're doing is you're basically dividing 2x cubed minus x squared minus 18x plus 11 by 2x minus 1. So first things first, we're going to find out the value of x, for which we'll do 2x minus 1 equals to 0, which means x is equals to 1 upon 2. And this is the value that we are now going to plug in. For this, I would strongly suggest that you use your calculator and do not try and work this out mentally. I mean, even if you do try and work it out mentally, that's great, but make sure that you check your answer towards the end. So let's work it out. So we have 2 into 1 upon 2 cubed minus 1 upon 2 squared, okay, plus, sorry, minus 9 plus 11. Okay, so we're looking at 2, so that means the remainder is equals to 2. Remainder is equals to 2. Okay, so let's just double check. 2 into 1 upon 8 minus 1 upon 4 minus 9 plus 11. Yeah, there you go. The remainder is equals to 2. Okay, so this is what you do when you have to find just the remainder. Okay, now there's a twist in example 2. In example 2, the question says that you have a certain polynomial which when divided by x minus 1, so you're already given the remainder, okay? So that means you know what this is going to be equal to. So first things first, we're going to find what value of x to plug in, for which we'll do x minus 1 equals to 0. That means x is equals to 1. Now we're going to take this value, plug it in the polynomial, plus a times 1, which is going to be a, and set it equal to 5 because that's what the remainder is. So 1 plus 1 is 2. 2 minus 2 is 0, so that means straight away we have the value of a, and that is equal to 5. Now you must have noticed that I'm not really putting brackets over here. That's because the value of x is positive. Had the value of x been negative, then we would have been very careful and would have made sure to put the bracket. Okay. All right. Now we have another example. Okay, so this example is slightly more complex than the previous two, and it says f of x is equals to x cubed plus ax squared plus 11x plus b. So I should probably write that down. F of x is equals to x cubed plus ax squared plus 11x plus b. Has a factor of x minus 2 and leaves a remainder of 24 when divided by x minus 5. Now, if it has a factor of x minus 2, what does that mean? That means when I plug in 2, since 2 is a factor, the remainder should be equal to 0. Okay, that's what we learned earlier. And leaves a remainder of 24 when divided by x minus 5. So that means when I plug in 5, I should get 24 according to the question. And why exactly do we need two equations? We need two equations because if you look at the question, you can see that we have two unknowns, and the only way to work out the value of the two unknowns is by having two equations. Okay, so let's do this one by one. Plugging in f of 2 means 2 cubed plus a times 2 squared plus 11 times 2 plus b equal to 0. Okay, so we have 8 plus 4a plus 22 plus b equals to 0. So that means 4a plus b, 8 plus 22 is 30, and taking 30 to the other side means minus 30. So that's equation number 1. Let's find out the other equation, for which we'll plug in 5. So 5 cubed plus a times 5 squared plus 11 times 5 plus b is equals to 24. So 5 cubed is 125 plus 25a plus 55 plus b is equals to 24. So that means we have 25a plus b. Okay, so here we got to be careful. So 125 plus 55 is 180, and then let's do 24 minus the answer, so that means minus 156. So now that we have the two equations, we can solve them simultaneously, and the method that I'm going to use is elimination. So I'll write 4a plus b equals to minus 30, and underneath this I'll multiply this equation by minus and write it. So minus 25a minus b is equals to plus 156. Okay, now b and b get cancelled out, plus b and minus b. Okay, that was the objective. 4 minus 25 is minus 21a, and minus 30 plus 156 is equals to 126. So what's 126 divided by 21? That's divided by minus 21. So a is minus 6, and now let's find out the value of b. So 4a plus b is equals to minus 30. So that means 4 times minus 6 plus b is equals to minus 30. So minus 24 plus b is equals to minus 30, which means b is equals to minus 30 plus 24. So that means b is also equal to minus 6. So there you go. A and b are both equal to minus 6. So just to be on the safe side, I would suggest that you use the feature in your calculator to check your answer, and that's exactly what I'm doing. So I have made a video on this, by the way. You can check it out and make sure that you check your answer. So 4, 1, minus 30, minus 25, minus 1, 156, minus 6 and minus 6. Yep, there you go. That means we've done it correctly. Okay, now here's another key concept, and something that's always worth at least 4 or more marks, and that is how to solve or factorize a cubic equation and expression. Now, before we do that, it's important to take a step back and recall what a quadratic curve looks like. Okay, now when we solve a quadratic equation, what we're basically doing is we're finding out x-intercepts. Okay, and that is why in some cases we have two answers, because we know a quadratic curve can cut the x-axis at 2 points. In some cases we just have one answer, because we know that a quadratic curve could also be tangent to the x-axis. Okay, or in some cases we have no answers at all. Okay, so in some cases you have two values of x, all right? In some cases, you just have one value of x, and in some cases, you have absolutely no value of x, okay? But that's what happens when you have a quadratic curve, okay? Now, what if you have cubic curves, okay? Now, you should know what the basic shape of a cubic curve looks like, okay? If you don't, just this is something you guys must have done in math, but if you don't, you can just look it up online and you'll see that that mostly a cubic curve will look something like this, okay? Now, what's important to note here is that what can be the maximum number of x-intercepts a cubic curve can have, okay? So for that, a cubic curve could cut the x-axis like this, so that means you could have 3 values of x. All right, so the maximum number of values of x that you can have are 3. Or it's possible that at one point it cuts and at one point it's just tangent to the x-axis. Okay, excuse my drawing please. But in this case, you will just have 2 values of x. And in some cases, it's possible that you may just have 1 value of x. Okay, so it's important to keep this at the back of your mind that whenever you're solving a cubic equation, the maximum number of answers that you can have is 3 and the minimum number of answers that you can have is 1, okay? And that's because of the shape of the cubic curve, okay? Now, here's an example and we're gonna learn how to solve a cubic equation with the help of this example, and I want you to pay close attention. And there are 2 different methods which you can use, and I'm gonna be as elaborate as possible so that you can understand both the methods equally well. Okay, now regardless of whatever method you use, you always find the first factor through something we call trial and error. Okay, now what do we mean by that? What do we mean by trial and error? That means you plug in a value of x, okay, and see if the answer is equal to 0. If it is, that means it's a factor, the value that you've plugged in. If it's not, that means it's not a factor. Okay, now the question is, what value of x are you going to plug in? So the value of x that we're going to plug in are always factors of the constant. Okay, so you have -6, the factors of which could be plus and minus 1, plus and minus 2, plus and minus 3, or plus and minus 6. Now you won't have to go that far. You'll probably find the first factor within the first 2 or 3 values. Okay, so let's do just that. Let's find the first factor. So I'm going to plug in x equals to 1 and see what happens. So that means 1 cubed minus 6 times 1 squared plus 11 times 1 minus 6. And now, since we don't know whether it's equal to 0 or not, so we're not going to write that, okay? So this means 1 minus 6 plus 11 minus 6. Okay, so 1 plus 11 is 12 and minus 6 is minus 12. So 12 minus 12 is equal to 0. Okay, so that means we've hit jackpot at the very first attempt, which means that now we can safely say that x minus 1 is a factor. Okay, so now that we can say that x minus 1 is a factor, how do you find the remaining potentially 2 factors? Now we don't know whether we're going to have 2 factors or not, but we could. So how do you find the remaining 2 factors? That's what the question is. Okay, so in order to find the remaining 2 factors, like I said, there are 2 different methods that we can use. Okay, so I'm going to draw a line over here and hopefully I'll have enough space to cover both. Now to find the remaining 2 factors, like I said, you have 2 methods. Okay, so the 2 methods are, so let's write that down over here, remaining 2 factors. So the 2 methods that we have for remaining 2 factors, one is long division, which is something that I always prefer, or something called identities. Okay, so this is also a method that we can use. Okay, so let's first understand long division. Okay, and then we'll look into identities. All right, now for long division, what you do is, now remember, this is basically what you're going to divide, and this is basically what you're going to divide it by. Okay, so what we're going to do is we're going to take our expression, which was, whoops, sorry about that, x cubed minus 6x squared, was it minus, was it plus? Okay, plus 11x minus 6, and we're going to take this and divide it by x minus 1. Okay, and as the name suggests, long division, so it is not exactly long, but yeah, this is something that requires a lot of algebra, so make sure that you or careful about that, and also be careful about the signs. So what we do here is, the first thing that we do is we look at this x and we look at what we have over here, which is x cubed. So how do you turn x into x cubed? Well, you multiply it by x square. And when you do that, the entire expression, x minus 1, gets multiplied by x square, which means we now have x cubed minus x square. And then what you do is you subtract this expression like you would do with any other division and write down the answer. So x cubed minus x cubed gets eliminated, which is not a coincidence. This is what we wanted to do. Minus 6x square minus x square means this is going to become minus 6x square plus x square. So that means minus 5x square. And the remaining two expressions we bring down as it is, plus 11x minus 6. Okay. Now we have a new objective. Our new objective is to somehow bring this x equal to minus 5x square, for which we're going to multiply by minus 5x. And again, the entire expression gets multiplied. So that way we have minus 5x square plus 5x. And again, we subtract the two. So when you do that, minus 5x square minus 5x square gets eliminated, which I repeat is not a coincidence. This is what we wanted to do at the very beginning. Okay. And 11x minus 5x is going to give you 6x minus 6. Now we have a new objective, and the objective is to bring this x equal to 6x, for which we're going to multiply it by 6. And now we have 6x minus 6. And if you subtract this, you get 0. So that's it. This had to be 0 because what we divided a polynomial by a factor. So that means the remainder, one way or the other, had to be equal to 0. And if the remainder is not 0, that means you've done something wrong. Okay. Now, remaining two factors, we have done long division or identities. But what you do now is you further factorize the quotient. So that means now I'm going to factorize the coefficient x square minus 5x plus 6. And let's set this equal to 0. So we can do middle term breaking here. So we have x square minus 3x minus 2x plus 6 equals to 0. So we take x common, x minus 3 minus 2 common, x minus 3 equals to 0. So that means x minus 2 times x minus 3 equals to 0, which means x is either equal to 2 or x is either equal to 3. Okay. Now these are the two factors that we now have. Remember that we found out the first factor through trial and error. So that means the three factors are now 1, 2, and 3. Okay. So this was one method. Now let's look into the other method. And the other method, which I mentioned here, is basically identities. Okay. Now before we dive into this, x minus 1, the first factor, was basically a linear equation. Okay. Now we need to think, what should we multiply the linear equation with so that we end up with a cubic equation? Now, if you do some thinking, the maximum power in a linear equation is x, and the maximum power in a cubic equation is x cubed. That means you need to multiply it by x square. So the answer is that you need to multiply it by a quadratic equation. So what we're going to do now is we're going to have x minus 1 multiplied by the general form of a quadratic equation, which is ax squared plus bx plus c, and set it equal to our polynomial, which is x cubed minus 6x squared plus 11x minus 6. Okay. Now this again requires a lot of algebra, so we multiply x with all the three terms. So you have ax cubed plus bx squared plus cx minus ax squared minus bx minus c. And this is something we say identical to x cubed minus 6x squared plus 11x minus 6. Now what we do at this point is something called comparing the coefficients. Okay, so first thing we're going to do is we're going to rearrange the left hand side nicely. So we have ax cubed plus bx squared minus ax squared plus cx minus bx minus c. Okay, and we're just gonna copy paste the right hand side. Let's do that. Okay, now again in the left hand side, what we're going to try and do is we're going to try and scrape off the coefficient. So you can see that you have x squared in multiple places. So if I take x squared common, so that's going to be b minus a, and then if I take x common here, that's going to be c minus b, and then minus c is identical to, again, let's copy paste this. So there you go. Okay, so this is the point where we start comparing the coefficients. So if you look at the coefficient of x cubed on the left hand side, it's a, and on the right hand side we have nothing, so that means it's 1. So a is equals to 1. Okay, now if you look at the coefficient of x on the left hand side, that's b minus a, and the coefficient of x on the left hand side is minus 6. That means b minus a is equals to minus 6. And now that we have the value of a, so b minus 1 is equals to minus 6. That means b is equals to minus 6 plus 1, which is equal to 5. Okay. And then for the value of c, you could either do c minus b and set it equal to 11, or if you want to find it directly, what you can and what you should do is, let me switch to a color that I haven't used so far. So I think I haven't used this. Okay. In fact, let's use purple. You can straight away use minus c and set it equal to minus 6, and that way you have the value of c, which is equal to 6. And now that you know what a, b, and c is, that means you now know what your quadratic, by the way, b is equals to minus 5, it's not positive 5. That means now you know what your quadratic equation ax squared plus bx plus c looks like. It looks like x squared minus 5x plus 6. And then you can further solve this equation and you will get the same set of values, x equals to 2 or x equals to 3. And then finally you can write your answer, x equals to 1, 2, or 3. Now what we've done here is we have solved this equation, okay? And we have solved this with the help of the first factor was determined through trial and error, and then the remaining two factors, you could do long division for that, or you could use the identities method, okay? Okay, so we have another example here, and if you notice here, it's asking us to factorize. It's not asking us to solve. In fact, it's asking us to factorize. Now, what's the difference? The difference is that when you're asked to factorize, you leave your answer in the form of, let's say, x minus 2, x minus 3, just like that. But when it's asking you to solve, that means you need to give the value of x, okay? So again, we're going to use the same procedure. So we're going to find the first factor with the help of trial and error. So we're going to start with 1. The numbers that we're going to plug in are obviously going to be factors of 15. So that means 1, 3, and 5, plus and minus. So let's start with 1. So that means 1 cubed minus 3 into 1 squared minus 13 into 1 plus 15. Okay, so 1 minus 3 minus 13 plus 15. So, well, we've been very lucky so far. 1 plus 15 is 16, and minus 3 minus 13 is also minus 16. So 16 minus 16 equals to 0. That means x minus 1 is a factor. Now for this, I am just going to use long division. I'm not going to use both the methods, but if you find identities a lot easier than long division, then I'd suggest you stick to identities. So x cubed minus 3x squared minus 13x plus 15 is divided by x minus 1. So what do I multiply x minus 1 with in order to turn it into x cubed? The answer is x squared. So we have x cubed minus x squared. Now we subtract this. So x cubed and x cubed gets cancelled out. Minus 3x squared minus x squared becomes minus 2x squared minus 13x plus 15 brought down as it is. Now we multiply x by minus 2x, so that turns into minus 2x squared. So minus 2x squared plus 2x, because minus minus is plus. So this gets cancelled out. Minus 13 minus 2x is minus 15x plus 15. So we multiply this by minus 15 in order to turn it into minus 15x, and then we have plus 15 again. So this gets cancelled out and it reduces to 0. So that means we've done it correctly. And now what we have to do is we have to further factorize x squared minus 2x minus 15. Factorize, remember, not solve, okay? So factors of minus 15 that give us minus 2. So they're going to be minus 3 and 5. So minus 3 and plus 5. Minus 3x plus 5x minus 15. X times x minus 3 plus 5 times x minus 3. That means we now have x minus 3 into x plus 5. And now for the final answer, so we'll write this polynomial here, and we're going to write the factorized version of it. So that means x minus 1, the first factor, which we got through trial and error, and then x minus 3 times x plus 5, the factors that we got after we ended up with the quadratic equation. Okay, so yeah, so far we have covered two concepts along with examples, and I'll stop here for this part. In the next part, we will cover the remaining two concepts, and they are cubic curve sketching and cubic inequalities. So they're very important, and make sure that you guys watch the next part also. And in the next part also, we will be solving the past paper questions that I've mentioned. Okay, so yeah, that's all for this video. I'll see you guys in the next one. Until then, take care. Bye bye.